will get a copy of the recording. And
Okay.
as far as this Gotomeeting control panel, you can minimize that so you can get a bigger screen. If you go up next to the X, there's two arrows that are almost touching.
I got it.
You click on those, that's a toggle switch for minimizing it and maximizing it if you need to maximize it. For the most part, you don't really need to be looking at that control panel the rest of the way. The rest of the
Okay.
meeting, we'll be looking at my screen.
Okay.
And we'll just go through these problems one by one and talk about how we solve them. Now,
Sounds good.
another beauty is that I can write on this. I couldn't write in your book, but I can write on this.
Yeah.
In this first problem, let's just look at it. Any ideas?
So is the runner the thing down below? Oh, we're just talking about the circle, right?
Well,
It has nothing to do with the runner A.
they want to know what's bigger, X or the number 5.
Oh, okay.
This is a bit tricky. Let me go through it.
Oh, okay. So
Like
it's
a lot of these
go ahead.
things, like a lot of these things, you have to do something else before you can get to the solution. In this case, I have to make that triangle.
Right.
Now, do we know what that hypotenuse that I just drew in there is?
5.
Correct. Now, all radiuses of a circle are the same length. So that line would be 5. That
But X would not be 5.
exactly. X is less than 5.
Okay.
Therefore,
That makes sense.
you know that 5 is the bigger number. Now, this 3, 4, 5 triangle is an
Yeah.
extremely common triangle. You want to be able to
Yes.
recognize that in all shapes and forms. It won't always be 3, 4, 5. Sometimes it'll be 6, 8, 10. In other words, it'll be a multiple of 3, 4, 5.
Ah, good to know.
It'll be 30, 40, 50.
Right.
So when they give you two sides of it, in other words, if they didn't give us the 8 and they gave us 10 and 6, we'd see that we're looking at a 3, 4, 5 triangle, a multiple of 2 of 1, and therefore that would have to be 8.
Got it.
Now, you can use the Pythagorean theorem if you have to, but it saves you gobs of time recognizing 3, 4, 5 triangles.
Right.
You don't want to have to go through the Pythagorean theorem to solve that.
Nope.
All right. Let me scroll down to the next problem. Sorry, I have a... Right as you called, my dog went into a seizure.
Oh no.
Yeah, she's a border collie. She's about 5 years old. She gets them about once a week.
Oh
Uh,
no.
yeah, it's heartbreaking. She's on medication, but she just kind of seizes up, and it's just hard to watch. Sometimes she kind of thrashes about, and in fact, the way I heard she was having one is I heard a big crash out back, and I went out and my snow shovel was and my shovel were all on the ground, and she had you can kind of hear that sound in the background now. She's trying to move, and she can't move anything yet. She's kind of paralyzed.
Oh
Uh,
no.
but luckily, they only last for 10 to 20 minutes. So she should be fine here shortly. All right. Number 2. Runner A ran 4/5 of a kilometer and runner B ran 800 meters. Which one ran the most?
So in a kilometer, there are 1,000 meters.
Correct.
And,
So what is 4/5 times 1,000 meters? In other words, this I can replace with, hold on a second. Just a moment. I need to go up a notch and then take a picture of it. In other words, that kilometer I can replace with 1,000 meters.
There you go.
Now solve it. Now what's 4/5? And you have your calculator in front of you?
I can get it.
You should. You always want a calculator around.
So would I do 4 divided by 5 times 1,000?
Uh-huh.
$800. They're equal.
They're equal. Okay, let's see. A is bigger, B is bigger. Is C they're equal? I think so, correct?
Yes.
And then D is
you can't tell.
Figure it out. Okay. All right, let's go down again. Getting about one problem per page here, but that's fine. All right, so we got x less than y, which is less than z. So sorry, I got this new phone and my alarm is going off every 5 minutes. Oh, I know what's happening is I'm putting it on snooze accidentally. Let me close all of them. Yeah, I'm not sure I know how to dismiss it as opposed to putting it on snooze. Hopefully it won't go off every 5 minutes for the next hour. But okay, here is a perfect problem to try some numbers. And what I found is that that's going to be a very, very common method of answering these things. I'm taking a look at all 25 questions. And a lot of times, the only way I can figure out how to solve it is by trying some numbers. Okay?
So if you do 1, 2, and 3,
let's try that.
Divided by 3, that still equals 2, which is y.
Okay, so in that case, they're equal, correct?
Mm-hmm. Yep.
So what I want to know next, that doesn't prove they're equal for all numbers.
Exactly.
Because all I have to do is find 3 numbers where they are not equal, and I'll be able to answer D, correct?
Yes.
Very common thing to try to do with these things. Well, right now they're pretty even. I've separated each number by 1. Let's try something like 1, 11, and 12, where I have some separation between the numbers. Now, what's my average? Which is what x...
24 divided by 3 would be 8.
Correct. And that's what that is.
And that does not equal y.
That does not equal y. We are done with the problem. We can answer D and go on. We don't have to go back and also prove that we can find a situation where the average is greater than 1. In other words, once you've proved that they can be equal and that they cannot be equal, you're done with that problem. Okay. Now, how much trig have you had?
I took, I think I took a class in trigonometry in high school.
Okay, but it's been a while.
Or had some trigonometry in it.
Okay. Let's talk about one of the most common triangles taught in geometry.
The right angle?
which is a right triangle that is a 45-45. Now, that's also isosceles. In other words, that side is equal to that side.
Yes.
If you have two opposite angles that are equal, then their opposite sides are also equal. And vice versa. If I tell you I have an isosceles triangle, that means it has two equal sides and their two angles are equal. Now, if this were true,
Then
what would x over y be?
they would be equal to 1, wouldn't they?
Correct? But we're not looking at a 45-degree angle.
No, because of the 50-degree angle.
Well, if I adjust that picture,
That would mean y is bigger, right?
oh, notice that x is bigger. In other words, that angle that I
Oh, because it's wider, right? Okay, x has to be longer.
To 50 degrees, which
So then a is bigger.
x, and it shortened y, or it left y the same, but it definitely lengthened x, and so x over y is always going to be bigger. No matter what x and y are, as long as this angle is greater than 45 degrees, then it's going to be bigger. Notice that if I had a triangle that had a really steep angle, in other words, that might be 70 degrees, okay? Well, now notice how much bigger x is than y.
Yeah.
So as that angle gets bigger, x increases its distance relative to y. So that's always going to be bigger if it's 50 degrees. Now, the other way you could do this is with a trig function. If you remember your trig functions, and probably not since it's been since high school, but if I say the tangent of 50 degrees, that's equal to x over y, and my calculator will actually give me a number for the tangent of 50 degrees. And it'll be greater than 1.
Let me see if I can find that.
Now,
it says tan, so I just hit tan 50 or 5010?
Yeah, no, tan 50. And assuming your calculator is in degree mode, because it could also be in radian mode, but if it's in degree mode, it should give you an answer a little greater than 1.
Okay, so
what kind of calculator do you?
I had to, just my iPhone, so I had to do 50 and then hit 10 to get 1.19.
Okay, it certainly sounds like the right answer. So that'd be another way of doing it.
Okay.
If you remembered your trig functions, where tan is opposite over adjacent. So the tan of 50 degrees is always x divided by y.
So if it's cosine, would it be?
Yeah, let's do cosine of 50 degrees. Cosine of 50 degrees is going to be a number less than 1, because cosine is opposite over hypotenuse. And
okay.
This is always bigger. So x divided by z is always less than 1. So if you do cosine of 50 degrees, you're going to get something in the neighborhood of a half.
0.642.
Yeah.
Okay, that's good to know.
That's the way your trig functions work. I was a little surprised when I saw that problem because I didn't realize trig was covered. And it doesn't have to be covered. In other words, you can solve this problem without trig, as I did, by just kind of visually imagining how you get from 45 degrees to 50 degrees. Of course, you have to know that 45 is one of those special triangles. Let's talk about the two special triangles, because there's no getting around these. One of them is a 30-60, 90. In virtually every math course you are taught, they teach you both of these triangles. Excuse me. And the other is the 45-45 right triangle. And
is the 30-60 the one? It looks like it's too big to be a 3-4-5.
neither
triangle.
one of these are 3-4-5, but
Okay.
to bring it up, I'll draw a 3-4-5, and now you're looking at the three most important triangles you can memorize. The thing is, with the 30-60, what you want to really memorize are the dimensions. And for the 45-45, so now whenever you run into a 30-60 triangle, you'll be able to solve it just because you know that all the sides are proportional. So, in other words, if I gave you a 30-60 triangle and I said this side is 3, how big is the hypotenuse?
So it would be 2 times, wait, sorry, not 2. Would it be 2 times 3?
3.
It wouldn't be 6.
In other words, you take the same side, the side opposite the 30-degree angle, you divide it by that. So this triangle down there is 3 times this triangle. Every side is 3 times. So the hypotenuse would be 3 times 2, or 6.
Which is,
And this side would be 3√3. Okay. So you're going to get a lot of problems like this, where it's extremely helpful to know your, I call these the unit ones. The reason I use the word unit is because the side opposite the smallest angle is always 1 in both triangles. Now, the 3-4-5, we don't actually study what those angles are. Nobody does. The 3-4-5 is one of the more common triangles, but it's not because of these two angles. It's because it's the lowest perfect Pythagorean triangle. There's no 1, 2, 3 or 2, 3, 4. The lowest one is 3-4-5, where every side is a perfect integer, and it's the lowest 3 numbers that comprise a perfect Pythagorean triangle. But try to memorize these dimensions that you're looking at here. There's going to be certain things you want to memorize. Now, they're not always going to be on the same page, but this is so important, I would almost suggest taking your camera and taking a screenshot of this.
doing so.
Putting it on your list of things to must memorize.
Got it.
Okay. Let's go down to the next one. So again here, it's going to be difficult to do this algebraically. Okay? So I'm going to take a similar strategy as I did on an earlier one, where I'm just going to pick some numbers and see what I get. And if I can pick numbers where they're both equal, and then I can find a situation where they're not equal, then I'll know it's D. And if I pick numbers and they're equal, and I pick another set of numbers and they're still equal, and I pick a third set of numbers and they're still equal, and then I can safely say they're equal. So for X, I'm going to start out with numbers that are very evenly spaced, because that's usually what makes the difference. So let's make it perfectly evenly spaced. I'm going to split that thing up into thirds. You with me?
Okay.
Okay. Now, what is 1 minus 2/3?
So that's 3/3 minus 2/3, which equals 1/3.
Okay. And what is 2/3 minus 1/3?
1/3.
Okay. So with those numbers, they're equal. And again, the next set of numbers I'm going to pick, I'm going to distribute them not perfectly at all. I'm going to distribute them non-perfectly. I'm still limited. I got to be between 0 and 1, but I'm going to try 1/10 for x, and I'm going to try 9/10 for y. I still satisfy that top condition. Now what's 1 minus y?
1/10.
What is 9/10 minus 1/10?
8/10.
Problem done.
Okay.
Now there may be algebraic ways to do some of these that I'm not seeing, but you know, it doesn't matter. That method that I used there is actually pretty quick.
Yeah, it is.
And I would not have had to separate them by as much as I did. I would not have had to do 1/10 and 9/10. I could have done 2/10 and 8/10, and I would have seen once again that they were not equal.
Yes.
Okay, so P is the probability that event E will occur. S is the probability that event E will not occur. So what do we know about P and S? Their relationship.
They're opposites.
Well, the probability, hold on, I remember to take my screenshot here. The probability of something occurring is always 1 minus the probability that it doesn't occur.
Okay, I did not know that. Thank you.
Well, let's talk about rain. Let's say there's a probability that it's going to rain today. Well, it's either going to rain or it's not going to rain. This assumes there's only two possible outcomes. And in this case, that's what they're saying. They're saying either the thing's going to occur or it's not going to occur. Okay, so if the probability was that it was 3/10 that it's going to rain, well, that means S has to be 7/10. And that makes sense. If there's a 30% chance it's going to rain, then there's a 70% chance that it's not going to rain.
Right.
Okay? So that's always the case with probability problems, is that the probability of an event is always 1 minus the probability that the event will not occur.
Okay.
Bag of marbles, the probability that you'll pick a red, let's say, is 60%. Well, that means the probability that you won't pick a red is 40%.
Right.
Okay. Now, once you get that equation, that means P plus S, if I just fiddle with that equation a little bit, it's always 1.
Right.
I don't need to think of that as P plus S. Because all I need to do is think of it as always being 1.
Mm-hmm.
Okay. Now, let's compare it with P times S. First of all, probabilities always total 1. So if P were 3/4, S would be 1/4. If P were 1/2, S would be 1/2.
Okay.
If P were 0, S would be 1. And if P were 1, S would be 0.
Mm-hmm.
You can see what I'm getting at, but if you take the product of all of these, it's a number less than 1. In other words, when you multiply two fractions, both less than 1 together, you always get a fraction that's less than 1. In fact, smaller than the first fraction. Same
Correct.
thing here. That's 1/4. Now, in the worst case scenario, where the probability is either 0 or 1, product of those is 0. Product of those is 0. So in every case, no matter what P is and no matter what S is, P
It's always going to be small.
times S is less than 1. So quantity A is the larger quantity every time.
Good to know.
Right? These get fairly difficult. Like I said, I looked at all 25, and there were 2 or 3 there that really gave me problems, which presents an interesting dilemma for us. And that is, are you best served by spending the majority of your... I break up the difficulty of these problems kind of into beginning, middle, and hard.
Uh-huh.
And this one actually has super hard also. So the question is it in your best interest to spend a lot of time on the super hard? And my hypothesis is perhaps not. At least not until you get to a point where you're getting all of the easy and all of the medium correct. Once you do that, then I would definitely say let's go on and tackle the harder ones. It's a little like skiing. I don't know if you've ever skied, but you don't start on the expert slope. When you're a beginner, you start on the beginning slope. And once you've mastered that, you go on to the medium. And then once you've mastered that, maybe you try the expert slope. But
understood.
I'm not a big fan of this learning by forcing the hardest level problems on you. Some of these problems we could literally spend 30 minutes on. That's how hard they are. But it's only one hard problem. And out of, what do you get, like 25 problems on the average math portion?
Yes.
On 25 problems, you might have 2 or 3 hard problems. Really, you might have one really, really hard. And since it's a timed test, and another important part of the test is pacing yourself,
right?
Knowing how many minutes you have for each question. If they give you, say, 50 minutes to do 25 questions, then you know you're going to be able to have about 2 minutes per question.
Right.
Well, most students that I've ever run across never get done in time.
Mm-hmm.
Well, the problems you don't want to get to are the super hard ones. In other words, you want to make sure that you see every easy one and every medium one and every moderately difficult one. If you don't do a super hard one, it's no big deal lost. It would take you 10 minutes to do it anyway, even if you got the right answer. So the risk reward doesn't make a whole lot of sense to spend a lot of time on the hard ones. And that's just my feeling. Now, if you've done all the others and there's only one problem left and you got 5 minutes, spend all 5 minutes on that hard one. Go for it. But in general, that's never going to be the case. And in fact, what I tell everybody is make sure you get through the entire test and see every single problem with time to spare. Because what you're going to do is when you come across a really difficult one, let's say you come across one and you spend 2 or 3 minutes trying to do it and you still can't figure it out, then I would put a check mark by that problem, leave it, and come back if you have time.
Right.
If you don't have time, make sure you guess. You always want to guess. It's never advantageous to not guess.
Okay.
Okay? So if it's super, super difficult and you know that you're not going to have enough time, you're not going to be able to figure out even if you had 20 minutes, go ahead and guess the first time through. And that way you don't have to worry about coming back and making sure you put an answer in. And in terms of guessing, I don't think rhyme or reason matters. You could guess letter A for every single one you were guessing. You'd be just as well off. In other words, don't waste mental energy trying to figure out what guess. Not unless you have it narrowed down. If you have it narrowed down to where it's 3 out of the possible 4 answers, well, now you might want to spend a little mental energy because an educated guess is better than a non-educated one.
Mm-hmm.
But only if you have an idea. Otherwise, just pick any of them and go on.
Okay.
Okay, let's look at number 7. I don't know if we're even going to run into any of those hard ones. I think we will, but maybe not today. X is a set of all integers that satisfy the inequality. So tell me what that set of integers is that would satisfy that.
So 2 through 5 plus, so integers are whole numbers, right?
Correct.
So 2, 3, 4, 5.
And the minus of each one also.
And the negatives, right.
Because the negative, by the time you take the absolute value of it, it turns positive. So there's 8 members of that set.
Yes.
Quantity A says the absolute value of the greatest integer in the set. What is that?
5.
What's the absolute value of the least integer in the set?
2. So quantity A.
That's a beginner one. In other words, that's the easy slope. Okay, let me go down a little bit here and talk about this one. These are difficult to compare algebraically. So I'm going to take the same strategy I take whenever I decide to pick some numbers. Hopefully we can find some numbers that make them equal, and then hopefully we can find some numbers that make them not equal, and then we'll have our answer immediately. So
Okay.
X and M are both positive numbers, and M is a multiple of 3. So let's try some M's that are multiples of 3.
So 6.
Okay. So when I have X to the 6th divided by X to the 3rd, what's that equal to?
Isn't it equal to X to the 3rd?
Correct. You subtract the exponents. Now, if I apply 6 in quantity B, I get X to the 6th divided by 3, which is X squared.
Oh.
Now, that doesn't tell me that quantity A is necessarily greater than quantity B. What if X were 1?
It would still be 1.
Right, so I'd have 1 equals 1. So they'd be equal.
Mm-hmm.
But if X were 2, I would have 8 there, and I would have 4 there. They're not equal.
So
bingo.
We can't tell.
Exactly. So that seems to be a pretty successful strategy. Try to make them equal and then try to make them unequal. And so far, that's done the trick. The only time that's going to give us problems is when I try to make them unequal, I keep getting A is bigger, always. And if I can't think of any set of numbers that makes B the same or bigger, then I go with A is bigger.
Yep.
All right. How much do you remember about statistics?
Not much.
Let me give you the basics. And this is something else you want to memorize. Don't take a picture of it, though, until... Whoops, hold on. I got to take a screenshot of it. The most basic thing about statistics is a normal distribution.
All right, the bell curve.
Bell curve. Okay? Where that's the mean, and we'll call it X bar. That's the average. And standard deviation, that would
Is in
be
the middle?
x bar plus 1 standard deviation. And this mark over here is x bar minus 1 standard deviation. And then if I just, let me go out to 2 standard deviations, because that's what this problem is talking about. And so if I go over to here, I don't want to put so much on there to confuse you, because this actually is fairly understandable. When something is in the shape of a, or when it's normally distributed, we know that 68% of the curve lies within 1 standard deviation. And by that, I mean the area under the curve. So that's 68% of that total area. If I were somehow able to take the total area under the curve, I would find 68% of it is there.
Okay.
Okay. If I go out 2 standard deviations, plus or minus, you get 95% of the curve is between those 2 points. So from there to there is 95%. And to answer this question, that's all you need to know. What they're telling us is that a variable y is normally distributed with a mean of 200 and a standard deviation of 10. And now it's saying, what's the probability of the event is greater than 220? Well, 220 is 2 standard deviations to the right, correct?
Yes.
Well, the probability, the total area between that section and that section is 5%, right? If in the middle it's 95%, then it's 5%, and that's only half of that. So I can estimate and say that that is 2.5% likelihood.
On the right side is 2.5%.
This side only.
Okay.
The odds of a number coming in that would be greater than 2 standard deviations to the right of the mean is 2.5%. There's There's 3 numbers you need to memorize. The mean plus or minus 1 standard deviation covers 68% of the curve. The mean plus or minus 2 standard deviations covers 95%. And the mean plus or minus 3 standard deviations covers 99.4%.
Mm-hmm.
So it's really hard to get 3 standard deviations away from the mean, no matter what you're talking about. Now, these might be the average height of every woman in the United States, okay? Where the mean might be 5'4" and standard deviation might be 2 inches. So I would be able to say that 68% of the women are between 5'2" and 5'6". And I would be able to say 95% of the women are between 5 foot and 5'8". My numbers are probably a little off, but I was just using them for example. But that's how you can figure out things like that. And that's what you would expect, as long as you know the mean and the standard deviation. And in this particular problem, they've given you the mean and the standard deviation. So I'm comparing 2.5%, that's the likelihood that it's greater than 220, with 1/6. Which number is bigger?
Well, 1/6 if I remember correctly.
Use your calculator, because you can just go ahead and divide 1 by 6 and convert it to a decimal.
I thought I had that memorized, but I guess I don't. 0.16.
Yeah.
Yep.
Whereas this one over here converts, when I convert it to a decimal, 0.025. So quantity B is always bigger. 1/6 is always bigger than 2.5%. Interesting how they give this as a fraction, you get this as a percentage, and both need to be converted to decimals in order to compare one another.
Yeah.
So I'll bet that's another common practice that they do. All right, let me go down to the next problem. Certainly at any time, if you have questions, feel free to interrupt and say, hey, can you go over that again? Or I didn't quite understand that, or whatever.
Will do.
Okay. We got 15 minutes. Okay. So when I say the ratio of A to B, how do I write that?
A semicolon B.
Or A divided by B. In other words, ratio can be either one, okay? And it actually works a little bit better to use the division sign, and I'll show you why. I don't know what to do if I put 1/3 semicolon 3/8, but I do know what to do if I put 1/3 divided by 3/8. That's what the ratio of 1/3 to 3/8 really means. Well, how do I divide a fraction by another fraction?
You invert the bottom fraction.
And multiply.
And multiply.
So I end up getting 8.
So it becomes 8 over 3.
Oh, excuse me. I don't get 8. I get, yes I do. I get 8. What am I thinking here? Multiplying by 8/3. No, I get 8/9. Sorry. Right?
Right.
Okay. And the ratio of 8 to 9 is that. In other words, now I put it back in words. 8 to 9 means 8 divided by 9.
Okay.
So again, there's kind of 3 different ways to talk about ratios. You can talk about them as fractions. You can talk about them as 1/3 is to 3/8. Or you can talk about it as 1/3 to 3/8. So there's 3 different ways to talk about it. And they kind of mix all 3 of them up here.
Yep.
Which looks like something that they're fairly common or good at doing. Now, number 11. I spent a half an hour on this problem earlier today. These are going to be the most difficult problems on the GRE. They're combination permutation problems. When's the last time you had combinations and permutations?
I remember doing them in my statistics class in college.
Okay. Let's just talk about them in the general, and then at some point we'll look at this, the rest of this question. Don't think we're going to be able to do it today. By the time we talk about these in the general, hold on, let me open up drawing page here. If there's 2 things, there's combinations which take this form, For example, 4 choose 2 is the way you talk about that. And the formula for it is n factorial over n minus r factorial times r factorial. Now, factorials. In other words,
so hold on just a minute. I'm sorry.
Uh-huh.
The equation is what you wrote on the left?
That's the general form. N choose R.
And what's in the middle?
Just some
what the problem was.
numbers
Got it.
I put in, yeah. N is always bigger than R, or equal. You're never going to find an R that's bigger than N. And really here, I should have written this. I should have made that N choose R. There's the general formula for N choose R. It's n factorial divided by n minus r factorial times r factorial. Such that if I had something like 4 choose 2, that would be 4 factorial over 2 factorial times 2 factorial. Now, do you know what 4 factorial is?
That's 4 times 3 times 2 times 1?
Yeah. I remember we had another factorial problem. So factorials are going to be something else they're going to stress, I can tell, on their hard problems. Now, we want to simplify that. We want to figure out what number that's equal to. Well, the 2's cancel. That 2 cancels and makes that a 2, and we end up with 6. So 4 choose 2 equals 6. Now, let me give you another one just for practice. Tell me what 6 choose 2 is.
Hold on just a second. I'm catching up with you.
Okay. The part you want to memorize is that part right there. I'd say take a picture of it, but I've made it so sloppy that maybe I shouldn't rewrite it. There's 2.
Okay, I see. I understood where you got your numbers. Okay.
Okay. So what is 6 choose 2?
6 choose 2. Hold on a minute while I write it out.
Go ahead and verbalize it. And
that would be 6. Say that again.
Go ahead and verbalize it, and I will write it on paper, and then we'll attack the problem with both of us looking at it on my screen. I think that's probably.
So the question I have, is why is it 2 factorial under the?
Well, the first 2 factorial was n minus r, which was 2. The second 2 factorial was r factorial, which was also 2. This one's going
So the n part is, hold on, the n is 6.
Correct.
So I put the 6 factorial, and then n minus r would be 4 factorial underneath.
Correct.
And 2 factorial.
Correct.
Okay, that's what I was trying to figure out.
Let me back up a second here. Yeah, we'll just cover these basics here. There's 2, let me start from scratch here. Here's what you want to take a picture of. N choose R equals n factorial over, I should have done the P first, but that's okay, n minus R factorial times R factorial.
Okay, I have that written down in my notes.
Okay, the P is a little easier to memorize. That's just n factorial over n minus R factorial.
And what does P mean?
P is permutation. So this is expressed in pick R. And the difference between when you select choose and when you select P has to do whether order matters. If order matters, then you want to use a permutation. If order does not matter, you want to use a combination. For example, if I said you have 10 books, all kinds of different books, and you can pick any 4 to go on a trip. And the question is, how many different combinations of 4 books could you select? That's where you use these. And notice that it doesn't matter whether you get books 2, 4, 6, and 7 or 7, 6, 4, and 2. The order does not matter. You're going to have 4 books to read. So it's a choose problem, not a permutation problem. We'll get to permutation problems later, but this particular problem, number 11, is a choose problem because it says you got a list of 10 books and you get to choose 4 of them. So let's just figure out how many different combinations you would get if you picked 4 books out of a group of 10. Well, that is 10 choose 4. You with me?
Yes.
Well, what is that? Tell me.
That would be 10 factorial divided by 6 factorial times 4 factorial.
Yeah, now the way to simplify these is you don't necessarily do these in your calculator. We know that 10 is 10 times 9 all the way down to 1, and 6 is 6, okay? So the 6 factorial, if I cross that out, the only thing I'm left with in the numerator is 10 times 9 times 8 times 7. Okay, and that's the standard way you do these. You cross out whatever you can. You take the biggest factorial in the denominator and you cross out everything else. Well, now we still have 4 times 3 times 2. Well, I can cross that out, and the 4 and the 2 times the 8. And so, and the 3 and the 9 is that, and I get 210. You could figure out 210 different combinations of 4 books.
Yep. Wow.
That is your standard combinations question. And it can be worded in any number of ways, like with books, or how about you go into an ice cream parlor and you're going to get a sundae that has 3 toppings on it.
Can I stop you a minute?
Sure.
On your simplifying that you did for this, did you cross out the 4 underneath with the 8 on top?
I crossed out the 4 and the 2.
4 and the 2 with the 8 on top. Okay.
And then I crossed out the 3 with the 9 and replaced it with a 3.
And then multiplied it and got 210. Okay. I was looking, I didn't see when you did that. Okay.
Now, these are available in a calculator no matter what numbers you put in, but I'm not sure they'll be available in the calculator you'll have that they let you use for this test. And that would actually be worth knowing. If you can do a little research on what kind of calculator do they let you use for the GRE, that'll actually make our tutoring more efficient.
I can find that out.
Yeah, I would think you'd be able to find that out. So maybe either by next session or next week, if we know that, then we'll know how much time we have to spend doing these manually.
Sure.
Or if you had a calculator that you could just put in 10 choose 4, it's going to give you 210 immediately.
Sure.
Okay. Now, permutations, notice the reason I said I should have written permutation formula first, notice that it's n factorial over n minus r factorial.
Yes.
The only difference is the choose one has another factorial in the denominator.
Right.
And the way I always remember it is I know I have two n's and two r's. So when I get to this point right here where I know I've got the permutation formula, I always used to say, well, now is that an n factorial or an r factorial? Well, if I remember that it's got two n's and two r's, then it's got to be an r factorial for the choose.
Two n's. Oh, I see. You got it.
They're in the formula. There's two n's and two r's.
Got it.
As long as you remember that, then you'll never make the mistake of letting that last one be n factorial.
Okay.
Now, there is some standards. 0 factorial is equal to 1. 1 factorial is also equal to 1.
Wait a minute.
Remember that. That's not intuitive.
Why is 0 factorial equal to 1?
Good question. I don't know. I don't have the answer. It's
Okay.
the only thing that makes everything work, but it's not that amazing in the sense that if I said, this also is a little surprising, 2 to the 0th power is 1, right?
Yes.
Well, guess what 0 to the 0th power is?
1.
Also. So that's no more amazing than that.
And
And
time
this
is up.
definitely true. If you were to graph a function x to the x power, and you start looking near the origin, you'll see the y value is 1. As the x, in other words, if I had x to the x power, and I start graphing that function, and I start looking as x gets closer and closer to 0, my y value approaches 1. So 0 to the 0 power is definitely equal to 1. And 0 factorial is also, even though I don't know how to explain it.
Okay.
But anyway.
So I will see you Sunday, right?
Yes, same time. And like I said, I won't call. I will just text the meeting ID number to your phone. And you should have, you see that icon over here I'm pointing at, the flower?
Yeah, I got that on my computer.
That is all you got to do is double click that, input the 9-digit number, you're going to be in the meeting.
Okay, great. Thank you so much.
Your default will always be audio, although I think your microphone will always be muted when you enter a meeting. So the very first thing you have to do is unmute that microphone. But if you forget, you can hear me. So if I don't hear you, I will say, please unmute your microphone at the top left. So even if you forget, it's easy enough to handle.
Okay, thank you very much.
You're welcome. Talk to you Sunday.
Bye.